All right, so now let's talk about sedimentary rocks. If you remember, a sedimentary rock is a rock that is formed from weathering, erosion, deposition, compaction, cementation. So basically, a big rock breaks apart into smaller rocks. Those smaller rocks are transported, and then they finally accumulate in some location, and they're pressed together to form this sedimentary rock. So what I want you to do is think about all the different places where this could happen. Maybe it could happen along a beach. Maybe it could happen beneath a glacier, or in a river, or in a lake. So there are many, many different settings where sedimentary rocks form. And each setting will lead to a rock that has different properties. For example, a sedimentary rock that forms along a beach might be a lot different from a sedimentary rock that forms from a giant landslide. The rock at the beach will have these really awesome, neat, fine sand grains, whereas the landslide sedimentary rock will be a jumbled mess of rocks of different sizes and shapes. It'll have big pieces, big chunks in it. Okay? So we really want to look at the properties of these sedimentary rocks, and then we can use those properties to be able to interpret what setting or environment that it came from. The first step to identifying a sedimentary rock is to determine what type of sedimentary rock it is. There are 4 different basic types of sedimentary rocks. There are clastic sedimentary rocks. There are biochemical sedimentary rocks, chemical sedimentary rocks, and organic sedimentary rocks. So a clastic sedimentary rock is a rock that is composed of a bunch of different rock pieces or fragments that are cemented together. Biochemical, also composed of rock fragments or pieces, but these fragments are fragments that came from living creatures like shells. So a rock that's a bunch of different shells cemented together is going to be biochemical. Chemical, that's where the rock has broken down into really small fragments or ions that can become dissolved in a solution. And then when these ions are deposited, they actually crystallize out or precipitate out of the solution. And then organic, that is a rock that's composed pretty much completely from organic material like material in a swamp. And that's coal. Coal is a very prominent example of an organic sedimentary rock. So if we look at those others, clastic sedimentary rock, you are going to identify that rock type by the size of the rock fragments and the shape of the rock fragments. Biochemical, in a similar fashion, you're going to look at the size, shape, and type of the organic fragments within it. And then a chemical sedimentary rock, you're going to look at the actual mineral material that rock is made out of. Okay. All right, so once you've determined what type of sedimentary rock that your rock is, then you can look at the details and figure out what actual specific kind of sedimentary rock that is. So once you've determined the subtype of sedimentary rock, now you can really look at the properties of that rock and determine the specific sedimentary rock that it's made out of. For example, if you decided that your rock is a clastic sedimentary rock, now you can look at the grain size and shape and determine, okay, is it a conglomerate? Is it a breccia? Is it a sandstone? Is it a shale or mudstone? Okay, and that's what we're going to do here. All right, so here in front of me, I have an example of 3 different types of clastic sedimentary rocks. Right off the bat, you can notice that they have different properties. They have different colors. In rock identification, especially sedimentary rock identification, color is not very helpful. There are a number of reasons that a rock can have different colors, and the same rock type can actually have a lot of different colors, a lot of different variations of color. So the main thing that we're going to look at, you'll notice that I have my ruler here, is the actual size of the fragments that make up these rocks. So just with a quick observation, can you tell which of these rocks has the largest fragments or grains and which has the smallest? All right, so I'm hoping that you picked this one as having the largest. You can see that it's made up of many different, quite large rock fragments that are very easily visible even at a distance. And then these others have smaller, okay? If you compare these two, you might notice that this one you can actually see some of these grains. I can definitely feel it with my finger. And then on this one, it's actually really smooth, and I would need to get some pretty good magnification to actually see the individual grains. So this one has the largest grains, second largest, smallest grains, or clasts. All right, so I can take my ruler and I can measure a few of these in millimeters. So that one, it looks like it's about 15 millimeters. That one is about 5 millimeters. So I can kind of measure a few of these and average it out, get kind of an average clast size, and then use that clast size and use the really neat clast size identification chart that I provided you to identify what rock it is. Okay. So on this one, since I'm seeing clasts between 10 and 20 millimeters, I would refer to this one as a conglomerate. Okay. I also am noticing that most of these clasts have more of a rounded shape to it. Some of them have corners and edges, but for the most part, these corners are rounded out. If all of these clasts were really square or triangular or angular in some sort, then I would refer to it as a breccia. Okay, so if I look at this one and measure these clasts, it gets a bit harder because they're so small. But it looks like a lot of them are about 1/4 of a millimeter to 1/2 a millimeter. So this would be about a medium grained sandstone. Okay, and on this one, this does me no good. I can't use this to measure the grains. I can't even see the grains with my naked eye. So because the grains are that small, I know that they're less than a certain size, and I would just refer to this rock type as a shale. Another clue that's helpful are features called sedimentary structures. So you might notice that this rock has a bunch of ridges and troughs, crests and troughs to it. This is referred to as a ripple pattern. Maybe you've seen sediment that's not yet rock that looks like this along the beach or along a river or a lake. That can really give me a clue as to what environment this formed under. So clearly this formed near some sort of moving water. Okay. And this one, I can see that it has these prominent layers in it, which is another sedimentary structure for this one. Okay. All right, so hopefully with that can give you some insight into the properties that you are really looking at when you are trying to identify a sedimentary rock.